Hey, welcome fellas to your next video in this series of demystifying LeetCode. In this video, we will discuss the problem rotate list of LeetCode. The link to the problem is placed in the description section of this video. So we have been given a linked list and we have to rotate the list to the right by k places, where k is a non-negative integer. So we have the list 1, 2, 3, 4, 5 and null and a k with a value of 2. So we rotate each element 2 places to the right and get the result as 4, 5, 1, 2, 3 and null. The problem statement is quite clear, so without any wasting time, I will discuss my approach. However, I strongly recommend to definitely do try the problem on your own, and if you cannot solve it on your own after much of hair pulling, only then go ahead and watch the solution. So say we have a linked list of size n which is less than k, say a linked list of size 3. Since the length of the list n is smaller than k, the linked list after every n rotations bounces back to the original form without any change. So we can safely ignore all the rotations that are multiples of n and only rotate the list k percentage n times. So the problem breaks down to rotating the list not by k times but by k mod n times. Okay, now in order to rotate the list k mod n times, we can run a function rotate right by 1 which rotates the linked list in one time to the right, and run that function rotate right by 1 k mod n times. Now let's understand how we can write this function rotate right by 1. Okay, now understand this. Whenever the list is rotated, two things happen. The tail node or the last node of the list after rotation becomes the new head, and the penultimate node or the second last node becomes the last node. That's the node that to whose next pointer points to null now. So we do these operations inside of the rotate right by 1 function. In order to make the tail node as the new head node, we insert the tail node at the head of the linked list. For that, we create a separate function called the insert front function, to which we pass the reference of the last node. Now we want the penultimate node's next pointer to become null. For that, we get to the penultimate node of the linked list and set its next pointer to null. It is important to note that if the list is null or the list has only one node present, we return the list as unchanged, because a null list cannot be rotated, and rotating the list with only one node will not alter the list. Now let's see the insert front function logic. In order to insert a node to the front of the linked list, we point the next pointer of the node to the current head of the linked list. Also, we shift the current head of the linked list to the node now just inserted at the front. Now, in the rotate right function, we use a for loop to run the rotate right by 1 function k mod n times. So now, with all the brainstorming done, we jump to code. So we first create a count nodes function in order to get the length n of the linked list. So let me just loop over the linked list nodes, increment the counter at each node and stop when we reach the null node where we return the count. Now let's create our insert front function, which takes in the head of the linked list and the node that we want to make the new head. We simply point the next pointer of the node to the head node in order to insert it into the front of the list, and then we just return the new head, that is the node itself. Now we create our rotate right by 1 function which rotates the list right by 1 place. The function accepts the head of the list. We check if the number of nodes that the list has is less than or equal to 1. If so, we return the list unchanged. However, if the list has more than one node, we go to the penultimate or the second last node. So let me just loop over until the next pointer of the node we are at becomes null. Meaning, when we are out of this loop, we have a reference to the second last node. Now we create a copy of the next to the second last node or the tail node and pass it to the insert front function in order for it to be inserted at the end of the list. As the insert front function returns the new head, we store the new head pointer and store it in a COP pointer variable. Now we make the next pointer of the second last node point to null, thereby making it the new tail node. Now we simply return the new head pointer. Now in order to avoid errors, we add a return null statement below also in order to tell the compiler that this non-void function or this rotate right by one function necessarily returns a value as the return type was specified. Finally, we create our rotate right function in which we first count the number of nodes. Let me store it in the value count, and if count is non-zero, we could safely divide by count, and hence we update the value of k or the value of the number of effective rotations to k percentage count. With the new k value set, we call rotate right by one function k times, each time supplying the new head for the function to operate upon. Finally, we return the new head. So let me just check this out if it works, and yeah, it does. So I finally now submit the code and see we get a success result. So our runtime is 12 millisecond, which is faster than 12.51% of C++ online submissions for rotate list. The memory usage is 11.7 MB, which is less than 46.94% of C++ online submissions for rotate list. Let us discuss the time and space complexities. The count nodes function and the rotate right by one function has order of n complexity, n being the size of the linked list. And since the rotate right function internally executes the rotate right by one function k mod n times, where k is the input and n again being the size of the linked list, the overall time complexity for the problem is of the order of n multiplied by k mod n. Now since k mod n is necessarily less than n, we can surely say that the time complexity is surely less than the order of n, which leads us to conclude that the algorithm time complexity is order of n squared. The algorithm uses constant space. If you like this video, hit the like button. If you want everyone else to like it too, then share it with your friends. And if you want to stay notified of upcoming videos, subscribe to iTalk Code. See you in the next video. Till then, happy coding.